This is a quick live demo to show what RIoT Secure does. Basically a secure device lifecycle management for IoT, and we're going to be showcasing a commercial deployment, but also what we offer developers. So first of all, what we're going to look at is what we do for one of our customers, which is Scandinavian Airlines, ground service handling. We've built a custom device for them that looks like this. And what we basically have here is a module, which is an MKR device, which I'm pointing at right now, which is actually where our client stands. And this controls the communications, security, and lifecycle management of a dedicated microcontroller that SAS can use to write edge applications. And if we were to flip the board on the other side, then we can see right here is the dedicated ATmega 2560. And if you're familiar with Arduino, you would kind of understand that there are no real lifecycle management solutions for these type of microcontrollers. So what we've offered is a dual microcontroller environment where we have a dedicated microcontroller for the internet and communications, and then we can allow the customer to focus on what they do best, which is writing firmware for the ATmega. So if we switch across to the management console, I can bring this up, and here we have a image of actually a map of Stockholm Arlanda airport, and we can see a variety of different telematics devices being deployed. Actually, we just saw some move up here, so obviously these are now currently in operation. So these are installed on ground service handling equipment at Stockholm Arlanda airport. And if I was to click on one of these devices, we can see this one is a TBL, which is a pushback vehicle. And what we can see here is we can see that we're monitoring the power of the machine and what's being provided to our telematics. And we can also see stuff like the network configuration, the fact that it's actually off right now, so no one's using it. But more importantly, we can see we've got two microcontrollers on the board, on the device. So one is a modem, which is ours, which runs the core firmware, and then we have the application firmware, which in this case is using a Linde firmware, which is absolutely wrong. So what we're going to do now is let's go back and change that to what it should be. So now I can view the device. So it says a lot of devices deployed. And here I've opened the device. I can see that this is the TBL and it's using the GSM modem. I can then see a dedicated microcontroller and it's running the Linde firmware, which it shouldn't. So let's go ahead and correct this. So I'm going to put on the driver handling firmware and I'll do the update. So what's happening now is that the device will eventually make contact with the server, which should happen very soon. So we can see here that the last communication was 3738. And if we were to make this visible, we should see an update come through shortly. And what will happen is there's just been a request now at 3841. It's going to now download the firmware. And then when it's complete, it will actually communicate again and then give us a confirmation that it's changed the firmware from the Linde firmware to the driver handling, which is the firmware that it should have. And if we just wait a little while, we should see this communication come through shortly. Patience is a virtue when it comes to live demos. And here we go. And then we can now see that the firmware has now been updated to driver handling. So this is a live demo of a real deployment at Stockholm Arlanda airport. So that's great. So I want to then switch the focus to this little device. And I'm not sure if you can see this clearly, but if we look at this, we can see this is an Arduino UNO R4, and it's using, it has an ESP32 for typically used as a communications module for the Renesas dedicated microcontroller here. And what we've basically done on this device is we've repurposed the ESP32 to be a client of ours. So through this, we actually be able to manage the Renesas microcontroller exclusively through our platform. And to demonstrate this, I'm going to update the firmware of the UNO R4. So let's go to our management console here. We can see the UNO R4s here. If I click on this, we can then scroll down and we can see that this is running the Invaders firmware. I'm going to then change this to, say, show RIoT instead. And I'll do the update, which is right here. So that's now going to be requested. And then as a bonus, we have a console, which is showing us a communications log, and this is where the device actually is now polling, or actually waiting for a poll cycle. So every minute the device will communicate to the server. So right now, if we go back to the device, we're still running the invaders. And if we wait, and it doesn't take long, we should actually have a new communication, and at that point it will request the download of a new firmware. So timing is key for making short videos. So hopefully this is a great video for everyone. And there we go. Now you can see it's going to download the firmware. So it's downloading the firmware over the Wi-Fi connection, because that's what was actually available within the ESP32. Downloads nice and quickly. Now it's going to decompress the firmware, and then it's going to validate the firmware and actually eventually write the firmware. And then we actually will see the Space Invaders change to a simple text message showing RIoT. And at the same time, so you see it's now erasing, it's restoring a bootloader. And now it's writing the firmware. So this is reprogramming the Renesas over the SWD pins, which are connected between the ESP32 and the Renesas microcontroller. So our client has a variety of different drivers for different microcontrollers. Now it's verifying, and it's success. And if I would switch back to the microcontroller, or I bring it to the interview, we will now see it says right. So it's now changed the application. So the Space Invaders are now gone. It's done a communication with the server, and if we go back to the server, we can now see that it's running the RIoT firmware. So thank you for watching this presentation, and hope to hear from you guys soon.